Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about multiple catch blocks in Java. So by the end of this video, you will understand what multiple catch blocks are, why multiple catch blocks are needed, how Java selects the appropriate catch block, and the importance of order of catch blocks. And we will see best practices for using multiple catch blocks. Okay, so let's get started. So we'll see handling different types of exception using multiple catch blocks. So why do we need the multiple catch blocks? Why can't we go for a single catch block? Okay, so the answer to this question is a program can throw different types of exception. Okay, it can be either arithmetic exception, index out of bound exception. So there are many exceptions. Okay, a program can throw. So each exception may require different handling. So let's say if we are getting arithmetic exception and we want to deal separately, and we are getting some array index out of bound exception, we want to deal separately. What do we mean by deal separately? Means if we are getting arithmetic exception, so after getting exception I will be doing something else. And if I am getting array index out of bound exception, then I will be doing something else in the code. Okay, so based on the exception we are getting, we will perform certain actions. So that's why we need different catch block, multiple catch block. Okay, so multiple catch blocks allow us to handle each exception separately. Okay, so a program can encounter different kinds of exceptions during, depending on the situation. And since different exceptions require different handling, Java allows us to define multiple catch blocks. Okay, and always remember, catch block will always be coming after single try block. Okay, let's see the syntax, how the multiple catch blocks we can write. Okay, so this is the basic syntax of multiple catch blocks. So there will be one try block, okay, one try block and multiple catch block. See, catch and the catch. So that's we call multiple catch block handles a specific type of exception. Okay, so let's say in the try block we are writing some code and it might throw any exception. We don't know what exception it will throw. Okay, so in this code, that's why we are calling it as risky. Why? Because it might throw any exception. And let's say if it is throwing an exception, arithmetic exception, then this particular catch block will it will execute. Okay, and if this catch block is executed, the other catch blocks, it will not execute, it will directly go to the end of the block. Okay, and it will execute remaining lines of code. So if we are getting array index out of bound exception, so on the statement which we are getting this exception, array index out of bound exception, it will try to find out matching exception block, catch block. Who will find? Java. So Java will find matching exception catch block. So okay, array index out of bound, so this is the catch block, so it will directly execute this block. And let's say apart from this arithmetic exception and array index out of bound exception, if you are getting any exception, okay, let's say null pointer exception, null pointer, in that case it will try to find out the matching catch block. So it will check whether it is null pointer, no. This catch block, no. This catch block, it is not a null pointer exception, but since we know the exception hierarchy, right? So parent class is throwable and child classes are, one is error and another one is exception. And further child classes are runtime, that is we call it as unchecked exception and checked exception. So this is what exception hierarchy. So whatever exception we have that belongs to checked or unchecked exception. Unchecked exception means inherited by the runtime exception class. So whatever exception class inherited by a runtime exception class, so those exception will be unchecked exception. Okay, and the classes which do not inherited by runtime exception are checked exception, and compiler forces to handle checked exception. Okay, so this is quick revision of exception hierarchy. Now, so all checked and unchecked exception, parent class is exception class. So in catch block, if I'm writing exception instead of specific exception, that means whenever the exception will occur in the try block, Java will find the matching catch block. But since we have not defined null pointer exception, so it will go to this exception and execute this block. Why? Because this exception is the parent class of all the checked and unchecked exception. So exception class is the parent class. That means if it will try to find out the specific catch block, and if it is unable to find specific catch block, it will execute this catch block, which is parent exception. That means if we have not explicitly we provided catch block for that particular exception, let's say null pointer exception, then this block will execute. So this is the parent class of all exception. Okay, so let's go to IntelliJ and see some example so that we have better clarity. Okay, let's say, so first of all we will write try. Okay, inside try block, let's say I'm setting result equals to 10 divided by 0. So we will get arithmetic exception. Now in the catch block, okay, in the catch block I will handle arithmetic exception, and here I will write so we know, right, we have method e.getMessage. We can directly print the reason of the exception, and I will write another catch block, that is array index out of bound exception. We will see what it is, but for now I'm writing the array index out of bound exception. So you don't get message. Okay, so it is a built-in method get message that will print the exception, why we are getting that particular exception. So let's say for now I will define this too, and after try catch block, remaining lines of code will execute. So I will write one line, program ends. Okay, so what we have written so far, so there is a try block, that is a risky code. Okay, in this try block we can get any exception, and we are handling a particular exception in this catch block, that is arithmetic exception, and array index out of bound exception is handled in this catch block. So each catch block is designed for a specific type of exception. Okay, so here line number 9 we will get which exception? Arithmetic. Okay, arithmetic exception will be occurred in this line, and after that what will be the execution flow? So after getting exception, what will happen? Java will create an matching instance, matching exception class instance. So it will create an instance or object of this particular exception class, arithmetic exception class. And after creating an instance of this matching class, so what do you mean by matching class instance? So matching class instance means arithmetic exception is the class name. Okay, this is the class name. So it will create an instance. Instance means new keyword and the class name provided by class name. So it will create an instance of the matching exception class, and after creating an instance, Java will check whether the programmer has supplied exception handling for this particular exception or not. So there is two cases. If programmer has supplied the exception handling for this particular exception, then in that case, that particular catch block will execute. So this is first case. And if suppose programmer has not handled this particular exception, that means programmer has not defined catch block for this particular exception. In that case, program will terminate in this line itself immediately. Okay, so after line number 9, whatever lines of code we have written, this line will not get executed. So in this case, since we have defined, handled, provided the exception handling for arithmetic exception, so after creating an instance, Java will find out, okay, programmer has supplied the arithmetic exception method exception handling catch block. So what it will do, it will execute this lines of code, this catch block, and after that it will go to the end of the catch block and it will execute the remaining lines of code. Okay, so what it will print, it will print the cause of the exception here in this line number 13. So from line number 9 to line number 13, and then it will go to the end of the block and line number 17 to line number 19. So this is the execution flow. So what will be the output here? Some reason, maybe divide by 0. Okay, and here program ends. Let's verify it. See, divide by 0 is the error message, exception message. Why we are getting this exception? Because divide by 0, and it is not executing this catch block. Okay, and after that it is executing remaining lines of code, that is program ends. Okay, I will show you how the execution flow. Focus on blue line. So now, so execution flow is currently in which line? Line number 9. Now focus where it will go. It should go line number 13. So 12, then 13. Okay, let's see. See, line number 12, it found the matching exception catch block, so it will execute. Line number 13. So in the console you can see nothing is printed, blank, but now it will print the error message, exception message. See, divide by 0 is printed, and after this line directly it went to the end of this try catch block and it will execute the remaining lines of code. Now it will print program ends. See, that's how the program execution flow is. Okay, now so here we have seen, right, divided by 0 throws an arithmetic exception. So here always remember this, after creating an instance of the matching exception class. Okay, we understood up to this one, new exception class name. Okay, so this, after creating an instance, it will throw this exception class. Why we are saying throw? Because Java will throw this exception, and this exception handling will catch those exception. So there is a keyword, we call it as throw. So whenever an exception is occurred at particular line, so at that particular line, that exception is being thrown, and in the catch block, that particular exception is handled. So in Java, so at the occurrence of exception, that particular line, throw keyword is used. In upcoming videos, we will see what is throw, and when we use, what is the difference between throw and throws. In the upcoming videos, we'll see. Okay. So for now, just understand the process. After occurring the instance, a matching instance class is created, and it is being thrown, and Java will check the matching catch block. So programmer has supplied the exception handling. So this catch block will execute, and after that, remaining lines of code will get executed. Okay. Now in the same code, I will modify something. I will comment this line. Now in the try block, let's say I am defining an integer array. Let's say numbers equals to, we have seen previously in the previous videos, right, how to initialize array. So this is an integer array. Okay, and let's say I want to print specific value of an index, let's say numbers, and let's say I want to print of index 5. Okay, so since, as we can see, the size of this array is 3, 0, 1, 2. Only 3 size is 3, but I am trying to access of index 5, okay, which is out of size of this array. Okay, so what exception it will throw in this line number 12? It will throw this exception, array index out of bound exception. By name it is clear. Okay, what it is telling, array index. Okay, array index out of bound. Out of bound means out of size. Since size is 3, but we are trying to get an index 5. Okay, so array index out of bound exception will be thrown in this particular line. Okay, throw, and what it will throw, the matching exception class instance. Matching exception class instance will be thrown. So after matching class instance is thrown, Java will check whether programmer has supplied matching exception catch block or not. If programmer has not supplied the matching exception block, catch block, then in that case, program will terminate in line number 12 immediately, and remaining lines of code in this program will not get executed. So this is first case. And let's say if programmer has supplied the matching catch block, in that case, that matching catch block will execute, and after that, remaining lines of code will get executed. So flow will be normal if you are providing exception handling for that particular exception in the catch block. So in that case, in this case, we have provided this matching instance catch block. So this catch block will execute. So it will print the error message, why we are getting this exception, what is the cause of getting this exception. It will print, and after that, remaining lines of code, that means it will print program, and let's verify. So here we can see index 5 out of bounds for length 3. See, it is printing the reason, the cause why we are getting this exception. And finally, the remaining lines of code will execute, and it will print program ends. Okay, so this time what is happening? Exception, array index out of bound exception, Java is keeping the first catch block. Why? Because it does not match and executes the second block. So it will find the matching catch block, matching exception catch block. So this is very important. So what is the flow? After getting an exception in any particular line inside try block, the matching instance class, matching exception class instance will get created and it will be thrown, and programmer will check whether the programmer has, Java will check whether programmer has supplied an exception or not. If it is supplied, then particular catch block will be executed, and after that remaining lines of code will get executed. And if programmer has not supplied the catch block for that particular exception, that means program will terminate in this line itself. Okay, so let's move now. How Java chooses a catch block, which catch block to execute, how Java will find out. Okay, let's say so exception is occurring in the try block. Now Java checks each catch block from top to bottom. Okay, it will check each catch block from top to bottom. So let's say the first matching catch block will execute. So it will follow sequence, okay, from top to bottom. So first catch block it will check, okay, exception is matching or not, no. Then again it will go to the next, okay, no. So let's say we have 3 catch block. Okay, and in this I am providing arithmetic exception, and in this array index out of bound exception, and in this I am providing exception class, which is parent class of all exception. That means if any if it is coming for this catch block to check whether exception has provided or not, then definitely this block will execute. Why? Because this is what parent class of all checked and unchecked exception. So this catch block will definitely execute. So if we want to handle specifically for some exception that we need to provide before this catch block. Why I am saying before? Because code will execute from top to bottom. So Java will start finding matching catch block from top. Then it will go and it will find the bottom. So from top to bottom, Java will try to find out the matching catch block. So this is arithmetic exception, that is arithmetic index out of bound exception, and this is parent class of exception. So if execution occur to find matching catch block in this catch block, it will definitely execute. So let's say we are getting null pointer exception. So it will check in first catch block. Okay, arithmetic exception, it is not the matching one. Then second catch block, array index order mode, this is also not matching. Then third catch block, this is exception catch block. So this is the parent class of null pointer exception. So it is a parent class of all exception. Okay, so null pointer exception. So this block will get executed. Okay, and if you, let's say if you want to execute null pointer exception separately, you want to do something else after getting null pointer exception. So in that case, you need to provide different catch block with handling null pointer exception. So now what will be the sequence? It will find first catch block. So it will execute from top to bottom. So it will check whether first catch block is having null pointer exception or not. Yes, it is having. So it will execute null pointer exception of the first catch block, and it will skip the remaining catch block. And after executing this catch block, the remaining lines of code will get executed. Okay. Why it is saying first matching catch block? That means, see, first matching means null pointer, okay, first block. And let's say even if this catch block we are specifying here null pointer exception and we have not written here, so it will try to find out first matching catch block. So first it will find arithmetic exception, no. So it find out the second. So this is like first matching catch block. And if we have not provided this one, then this catch block will execute. Okay. So whatever catch block that matches first, that catch block will execute. Okay. And remaining catch blocks are skipped. Okay. Skipped. Those catch block will not get executed. And after that, remaining lines of code will get executed. That means program continues after the try catch statement. So Java always checks the catch blocks in order. As soon as it finds the first matching catch block, it executes it and ignores the remaining catch blocks. Okay. So why I am saying first matching catch block, it follows the from sequence from top to bottom. Okay, let's go to IntelliJ, see some examples to get some clarity. Okay, so okay, I will arithmetic exception. Okay, I will remove this. I will write again try block, and inside this I will write result equals to 10 divided by 0. I am taking same example. So in this line we will get what, which exception? Arithmetic exception, right? So we need to provide catch, but this time instead of arithmetic exception I am providing exception class. So as we all know, exception class is the parent class of all exception, whether it is checked exception or unchecked exception. So this is like general exception, it can handle every exception. And after this I am providing arithmetic exception. Arithmetic means, yeah, arithmetic exception. Okay, and here I am writing, let's say e dot get message. Okay, now it is throwing. So you can see, right, compilation error is it is throwing, since after getting this exception, let's go with the flow. Okay, first it will get the exception, so it will create matching instance class of that particular exception and it will throw. Now Java will find whether programmer has supplied. So in this line it will be thrown arithmetic exception like this. Okay, and here will be something written divide by 0 like this. So this thing will happen. Okay, so it will be thrown the matching instance class, exception class. Now how the execution flows, how Java will find out the matching catch block, how Java will find the matching catch block from top to bottom. Okay, top to bottom means first it will check first catch block, then second catch block, then third catch block, likewise it will go up to bottom. So what is the exception class name? Arithmetic exception. So it will check the matching catch block in the first block, and since first block we are using exception class, which is parent class of all exception class, whether it is checked or unchecked, so this arithmetic exception will be covered as part of this catch block and this will be executed. Okay, since exception is the parent class of arithmetic exception, so this will get executed. Okay, so if this catch block is getting executed, then it will never go to the second catch block. So whatever exception, as we all know, exception hierarchy, right? So there will be throwable class, parent class, then exception class is the child class, then exception class is the parent class of all exception. So whatever exception we are getting inside try block, those will be handled in the single catch block. It will never go to the remaining catch blocks in this program. That's why it is throwing compilation error saying exception arithmetic exception has already been caught. That means whatever exception we are defining after exception class, that is already been caught in the exception catch block. So there is no use of this catch block we are defining after the parent class catch block. There is no reach here. Okay, because whatever exception class is thrown, that will be handled in this catch block. Okay, so the code does not compile because exception is parent class of arithmetic exception, and since the parent catch block comes first, it would catch every arithmetic exception and making the second catch block unreachable. That's why sequence are very important while writing the code. So we are writing the parent class, so it should be coming second if you want to execute explicitly. So this catch block should come first. Okay, and if it is failing, if some other exception we are getting out of arithmetic exception, then this catch block will be checked whether it is matching or not. So since this one is parent, every exception will be executed as part of this catch block. Okay, so here now the flow is normal. Now it will execute catch block and it will print program ends. So this is the correct order of catch blocks. Okay, so let's see some best practices we should follow while writing the code. So catch specific exceptions whenever possible. Okay, so let's see, we are already knowing, okay, we might get this specific exception inside try block, then we should specify the catch block for that particular exception. Okay, what does it mean? So let's say we have try block and I am thinking like I might get null pointer exception in the try block, then I should write catch block for null pointer exception. Okay, so this is what is specific catch block. It will handle only null pointer exception and then catch block for all exception. So in this line it is saying whenever possible provide specific catch block for specific exception. Place child exception classes before parent exception classes. This is important point. Just now we have seen with the example. So whatever child class exception, those should be present before, because execution goes from top to bottom. And always this parent class exception catch block should be at last, because if this catch block checking comes, means this will definitely execute because it covers all exception. And if we want to provide any specific exception to be executed, then that particular catch block should be defined before. Okay. Avoid unnecessary catch blocks. We cannot write for each and every exception, right? So meaningful catch block we need to write. So it is written here, keep exception handling meaningful. Okay, so to write clean and maintainable code, always catch specific exception first. Okay, that means place child exceptions before parent exceptions. So it will avoid redundant catch blocks and it will provide meaningful handling. So let's quickly summarize what we have learned so far. So one try block can have multiple catch blocks. Okay, we have seen with the examples. Each catch block handles different exception type. Okay, we have seen in the example how catch block will handle arithmetic exception, how catch block will handle null pointer exception, array index out of bound exception. So we can define a separate catch block for a specific exception. Okay, so Java executes only the first matching catch block. Okay, so it will do, it will see whether programmer has supplied the catch block, matching catch block or not. So it will execute from top to bottom different catch block and it will find first matching catch block. Okay, this is the catch block for that particular exception class. Then it will execute this catch block and it will come out of the statement and it will execute remaining line of code. So it will find out the first matching catch block. Catch blocks are checked from top to bottom. Okay, sequence is from top to bottom. Specific exceptions should come before general exception. That means child exception should be written before the parent class exception. So if we want to write parent class exception, that is exception, so that should be written inside, that should be written at the last, because this will cover every exception. So child class exception should be written first, then in the bottom we should have the parent class exception. So that's all for this video. I hope you understood the concept of multiple catch block in Java. Yeah, thanks for watching, and I will see you in the next video.